Hi, good morning, good afternoon, good evening, wherever you are. Hope you're enjoying the conference so far. I'm Kishore Jonnalagedda, Director of Engineering at Toyota. I'd like to talk about our journey into the platform, which we dearly call Chauffeur. Hope you recognize those cars. Yes, that's a Supra. Yellow one's an i4 in 255 HP engine, amazing horsepower. Until you drive the i6, the red one, which is 380 HP engine. And then comes the prototype, the silver one. We're going to talk about that. There is no best, only better, Aki Toyota. And we're going to learn all about how we Kaizen our processes in the platform. Before we jump into Chauffeur, I just wanted to touch on the fundamentals of how we operate it. Toyota Production System, TPS, you must have already known, which forms the foundation piece for a platform. And main things are core principles: high quality, low cost, shortest lead time. And the purpose is to eliminate any waste, which we call MUDA, and continuous improvement, which I mentioned earlier is Kaizen. Now, just like any other large enterprise company, Toyota has several thousand applications that were built for a specific need at the time. So, over a course of time, they were built for specific needs that arose for that market, locally optimized for their life cycles. Now, what does it do for a company from a cost point of view? Now, if you look at this, there between the thousands of applications, there's a lot of work that was repetitive, which is common. There was necessarily consistency gaps. Now, let's consider the factors that added up into the cost. There's obviously repetitive work, which is, there's common work, but happening the same way in multiple places. There were inconsistencies on how that work is being done. And of course, the sheer magnitude of the applications, I just mentioned thousands of applications, and the duration over which these applications have to be maintained, patched, and whatnot. Now, jumping into the mathematics of this, if you look at this from a cost point of view, the way we looked at it is cost per developer and security assessment engineers, number of developers is D, number of security engineers, number of hours to develop, number of hours to test, and of course, you put down the hours of security review. Now, if you add that up, and over time, when you multiply this across multiple teams, you get the bottom equation, which is the cost per year for the entire company is an addition, is a summation of entire costs for every single app to do to develop this thing and to actually patch it over time. So which is a significantly large number when you plug those in with numbers. And you can do it for yourself. We looked at it and it was time for us to rethink our strategy. Now, what are those core principles for the platform? So before we go build that, we wanted to make sure we set some boundaries on how we want to build. So first thing was discoverable. So we wanted to make sure that whatever we put out there is easily discoverable, easy to find, self-explanatory, and most importantly, self-serviced. Reusable. So whatever we build is generic enough that it can be reused across multiple teams. And of course, it should have a high multiplication factors. We have to choose those problem statements which will have the biggest bang for the buck. And then, of course, compatible. So whenever we see an application, application is always in an ecosystem. So we have to make sure that whatever we build in the platform is going to address the entire needs of the ecosystem, security, compliance, and et cetera, et cetera. So what we did is what we call Genchi Gembutsu. Genchi Gembutsu is to actually go and talk to the people who are trying to do it and see what they want. And then on top of that, eliminate muda, is eliminate waste. So that's what we did. We went and talked to people, and this is how our road to success, our road to a platform looks like. Now, first of all, of course, we wanted to make sure we standardize on the technology and processes. So we put in this technology. So we picked up the necessary tools, the necessary pipelines, the process. So think about this as the developer experience process and adopting, and where do we want to deploy it, some of the cloud platforms that we wanted to do, and we launched it out to our customers. And that's how it looked. Low quality, high cost, inefficient lead time, didn't meet any of our KPIs. So time to do another Genji Genbutsu at Kaizen. Now, why did our pipelines look like that? This is what our studies showed. Modern software is richer. And of course, there's lots of frameworks to learn. There's a lot of cognitive overload already for developers, a lot of moving parts and complicated to build. And when we talk to our developers, what they're thinking of is on the left-hand side. What the developers thought was their application, a web front end, an API, or a database, or things like that, whatever they run on the, in their laptop. But the reality, honestly, is a combination of both the left and the right, because there is a whole lot of tools that is needed to deploy the software. There's security scanning, there is configuration scanning, there is uniqueness to the database, how the cloud providers bring in, it varies by cloud. So all of this put together, and not to mention the day two activities and observability tools that need to be hooked in, all of those were afterthoughts for developers that just not come naturally. So that is what the realization for us and an opportunity for us to think about for a platform kind of paved the ground. So once we did a Kaizen on this, the one thing we decided as a goal is make it simple for product teams to build high quality products so that we can help from the platform point of view, we can build something to help these teams achieve those goals. So what did that road to success look like? Here's one thing, you've seen that picture before. Now the difference is while the development teams are thinking of one side, how about the platform team comes in and kind of reduces the cognitive load so that the adoption of the tools on the right hand side, be it the cloud, the pipelines, the security tools, or the processes, be simplified. And the contractual agreement that we're going after is how do we make everything as code? So essentially, acts as a template or acts as a code or a service level contract, so that there's a service level SLA or SLI, SLO, all those things are built into that code. So that is essentially the basis for us to form the platform. Our platform consisted of products and services, with of course some guiding principles. Now, the core principles that we use for our products are that they have to be discoverable, reusable, and compatible, just in line with the platform principles that I mentioned earlier. Now, for discoverability, we built a self-service portal. For reusability, we built blueprints. For compatibility, we adopted the X as a code model for all the products that we're building. And to help teams adopt these products, we provided key services in the form of principal engineers with subject matter expertise, cloud economics teams that went and ensured that the products are being used in an economical model, and SRE teams that are ensuring the day two activities are hooked and wired properly. And of course, there are fundamental guiding principles. We're not solving every problem out there, but we do love to have a community who can contribute back, and that's where the inner source model comes in, where there are certain areas where we may not be thinking right now, but that's something that aligns with our platform. We're more than happy to work together. Now, as a platform team, we have to make sure we're providing that undifferentiated value. So if you think about it, I'm going to give you an example real quick. So in this example, we're talking about Terraform, how to deploy a single page architecture application in the cloud, in AWS specifically. Now, what you might see is if you Google, you might find those modules that will help you deploy this thing, and teams typically stitch them together. And that's essentially what led to those pipelines that we saw earlier, like a big traffic jam, because they're not necessarily stitched in the same way. Now, this is where the platform team is going to add real value as you go down the chain. Now, or rather, in the diagram, you go up the architectural blueprint and then the reference architecture is where the real bang for the buck, and that's what the platform team is going to give. The architectural blueprints are aligned with our ecosystem. Now, same thing with the reference architecture. It's a completely functional application aligning with our application, with our ecosystem, our principles, our security models. So application team can take that and run with it. Now, here's another example of what that self-service portal looks like. Think of it as consumable blueprints. Maybe you press a button and fill in a few values, and you actually get the blueprint ready to be used for your specific need. Discoverable software catalog. So people might have built software, but how do you make it so that the search is easy? How do I know where that specific API is? So somebody which has already built and easy to consume. Education and training, which is very, very, very important for that whole self-service nature. Nothing is full unless there is a complete guide on how to use the product. And then, of course, the continuous engagements of things like cloud economics and FinOps, which kind of make sure that those costs are in check. And of course, and a lot more insights and metrics so that people can come there as app teams and various personas of the app teams. It could be a leader of the app team, multiple app teams, just that specific team, and figure out the metrics that are relevant for them. That is the real value for your Now let's look at that a little closer. Now here's a screenshot of our self-service portal. We've used a technology from Backstage, open source by Spotify, and we built on top of that in what we dearly call Chauffeur now. So as you can see, this is an example of one of those blueprints, and the real value here is how this fits into the various well-architected nature in our ecosystem. And all those stars and all of that tell you that. Now, what happened when we released these? Of course, there's multiple of these that we've released so far. And when app teams looked at that, the key metrics that we were looking for is what is the rate of adoption? Are app teams really interested in what we're giving them? And then, of course, which points in that adoption are they dropping? That's important for us to Kaizen and so that we improve upon ourselves. And what we realized eventually was, as we went through this iteration, the quality of the applications that are being deployed were improved. The cost efficiency immediately reflected because we already baked in all the good cost efficiency practices that we brought in from cloud economics. And of course, this improved the overall lead time for the application teams because it just fit the pipelines perfectly. We obviously wanted to Kaizen on the yellows, so to quality and to improve the lead time. And we went and did some Genchi and realized we needed to put some training material, some community-based training, exchange of best practices, build that model where people can talk to each other. And of course, there's a consistent educational form. And when we did that, and the other thing added to that we did was add surfacing the insights of applications. So there's various things going on. For example, an app is having a certain security vulnerability and score to surface it at the various personas related to that application. For example, a VP of that application suite might have a different view or a different score than the application specific team, but they're all looking at same metrics across the board. So they can further drill down or drill up as it goes. So this helped us automatically increase the quality and increase that the lead time and bring efficiency into that whole lead time. I want to circle back to the mathematics of this again one more time. With the platform usage, what is that looking like? Remember that CY equals sigma of? So this is where we did this, a reusable work, consistent results because these pipelines and the blueprints, they just gel well together, build once and use many times. And then, of course, the duration of managing these things, and the amount of capacity needed to manage this. Now, same formula, the top portion is very much similar to the cost of developers, but it's pertaining to the platform team. Now, as you go down from the number of hours of security reviews, what you realize is now there is a difference in number of hours to develop, which is a smaller number. and a number of hours to test, which is smaller, because what the application teams are doing are really adopting, not building, which is significantly less than what it takes to build. So when you look at the adoption cost instead of the dev cost, you see that the adoption time AD, which is it is a multiplication factor of the number of developers times the time it takes to adopt, and that number turns out to be much smaller than the actual time to build. And, and of course, the same thing with upgrades. So the cycle continues. So with even with X amount of teams, the same number of teams that we considered earlier, the total summation is a summation of how much time it takes to adopt the platform rather than how much time does it take to build their own software, which is, it turns out, is very significantly low. And we're going to see a few examples and some numbers we've revealed in other case studies. Well, if that math isn't that clear, let's look at some graphs. Now, drilling deep into this, there on the left side are the teams that didn't use the blueprints. On the right-hand side, the teams that used the blueprints. Now, as you can see, the lead time for the left-hand teams, there's a significant amount of time that they're spending in doing platform activities. These are all activities that we described on the right-hand side of that big picture of cloud tools and observability and whatnot. So these are tools that don't come out of the box. You got to gain some expertise. There is one thing to do, which is to learn to just plug in variables, and the other thing, which is to gain expertise and to build it according to the ecosystem. So as teams spent more time on the gray bar, they obviously didn't have time to build their own feature set, which didn't really help them move forward. So this is where there's a big difference between teams that started adopting the blueprints and other things that were given by the platform. And you can see here, this is a basic, generalization is at least 8 weeks of time that was shortened by application teams, that the application team themselves came back and told us. This is all, of course, it reflects in the Jira tickets and whatnot. And one more thing which the teams realized over time is that it also matters the subject matter expertise that the platform team has in the necessary tools and whatnot helps them move at a much faster rate to adopt the rate of change. So over a course of time, which becomes that multiplication factor in our equation, this is where teams would have to do and redo a lot of these things as upgrades happen, as new features are released in the cloud. So that's where the teams gain significant momentum from the application team, as opposed to the non-application team, non-platform based team that are building that thing. Well, now that we've seen that there is benefit if the platform team built the platform features and the application team built the application features, let's look at some numbers that we realized over the course of time. Now, these are numbers that you'll see in various articles that have been published. I put a reference there. But $10 million in saving, that's a pretty big number over the course of a 2-year period. 40 of those templates that are published. And as you can see, 8 weeks per team and across multiple, tens and hundreds of teams. So that's a significant number as we progress into this. But then we just started our journey. Well, now that you've seen that, is it enough to just build a platform? Well, no, not really. So it's a shared responsibility model. There is a portion of the work that the platform can give. Remember that contract, that equation in our developer versus platform features? That is where you would need the application teams to write and adhere to the platform needs. So there is work on both sides. There is work that the application teams would have to do for every feature that the platform team built in order to realize the benefits. And this is where you have to have the training, you have to have subject matter experts so this adoption gels well. And that's essentially when you can have your work-life balance. And that's how we see it. And that's how we are seeing that application team benefit from these things. Well, that's all I had. Again, here's a quick link to some articles and case studies that have been published. Feel free to look at them, mcio.com, Amazon case studies, Backstage, Spotify, you name it. And here's some awards that we've won over the course of time. But honestly, platform, building the platform, learning from it is a journey, and we're in the beginning stages of it, and we couldn't have done it with our application team. So thank you very much to everyone that is involved from the bottom of my heart. Again, thank you very much for hearing me out. I hope you'll take away something valuable from here, and good luck on your platform journey.